Hello everyone, I'm Modi from Retarget Common YouTube channel, and in this video we are going to learn about binary search. So sorting and searching algorithms are always hot topics in interviews, and I believe if you solve these problems it will surely improve your logic building skills as well. Okay, so for that I am going to cover the binary search in this video. So I'm not going to start with any definition of binary search. Instead, we'll try to solve a problem, and then we'll build up logic, and then we'll name it. Okay. So here, if you see on the screen, I have one array, and where I have 5 elements like 10, 21, 25, 32, and 46. So first thing I wanted to notice here that is this array is sorted. Okay, can we see like it's the elements are in the increasing order, okay, in this array. So first thing we can figure it out like element is already sorted. Okay, so how this sorted array can help us to search an element in this array. Okay, suppose I just want to search for 32. Okay, I need to find whether this array consists of element 32 or not. So in previous video already I have explained about the linear search, where we need to iterate the array and compare with the element. So means you need to take the first 0th index, first index, second index, and so on, and compare with your desired value, like suppose 32. Okay, and if it is matching, then you terminate the loop and you print whether at which index element is found, or in the worst case element is at the last position of the array or element is not present in the array. So you need to print the message as required. Okay, so in that scenario, in that case where we are not bothering whether element is sorted or not sorted, linear search will work. Okay, but here we found this array is already sorted, so how it can help us to find any element quickly. Okay, so already I've explained in my linear search algorithm, like in the worst case you may need to go and comparison. Okay, in which case where if the element is at the last position of the array or element is not present, then you need to go till last. Okay, so that is not optimal solution. Okay, but here we found one thing like array is sorted, and how can we take the advantage of sorted array to find an element. Okay, so let's stop here and let me give you one real-time example. So you people must have your dictionary, right? Or okay, so leave the dictionary, you must have read out some, you must be reading some books, right? Suppose we have one book, and in that book we have 10 chapters. So we know that in book generally means it should be in sorted order, right? Like chapter 1, chapter 2, and chapter 10, like that, in the sequence. So suppose you want to read the chapter 7. Okay, so randomly what you do, you go and open the page, open the book randomly, right? So if you're lucky, so you will get the chapter 7 only. That is possibility, right? You just open the book and you found the chapter 7. Okay, you are very lucky. Okay, but suppose you open the chapter 5. Okay, so can you guess or can you see like in which direction you need to go? Means you need to turn the next pages, right? Because chapter 7 will be obviously present after chapter 5 only, right? So we know that we need to go right side, means we need to turn more pages, right? But suppose when you open the book you found chapter 9. Okay, so we know that chapter 7 will be present before chapter 9, correct? So what you need to do in this case, you need to flip the pages from left side, correct? So we know how this is possible, how this logic is implemented, or how why you are thinking in such a way like whether I need to go to further or I need to go to backwards. Why? Because book is sorted, right? Chapters in books are sorted. Same thing we need to apply here. We can use the like sorted array to find the element quickly. Okay, so let's get started here. So suppose I want to find the element 32. Okay, one more thing. So in the example of book, what I said that I just simply open the book randomly, right? I am not driving any logic like which page number I need to open. Okay, but at least here we can have some logic. Here also you can apply the same thing, like you can pick any random element and then decide whether you need to go to left or right, right? But here instead of picking any random, why not we pick the middle element? Okay, means take the middle element, decide whether you need to go left or right, or the middle element is the desired one. Correct? So the to find the middle element of any array, that is like there are two formulas you can see. One will be like your starting index and end index. Okay, add both and divide by 2. Okay, or there is one another formula which is generally covers the edge cases of the first formula, right, in which the first formula will fail. Okay, so you can have, so let me write it first. So suppose we can use two ways to find the middle element. Okay, so suppose first one will be like mid, it will be your start index, okay, then end index, okay, and to divide it by 2. Okay, so in this way also you can find the middle element. Or there's another way you can do, like it is start, okay, plus end minus start, okay, and divide it by 2. Okay, divide by 2. So both the ways you can use the to find the middle element. Okay, so whatever way you want to use, you can use it. Okay, but the second formula will cover some edge cases where the first formula will fail. Okay, so anyway, that I am not covering, like how to find the middle element, but at that you can Google it more and practice. Okay, and you can find the difference as well. So here I will have starting index as 0, right, beginning of the array. So start will be 0 and end index will be like 0, 1, 2, 3, 4. 4, right? Or you can use like length minus 1. So if I try to find the middle element of this, okay, what will be middle element? Whatever formula you apply here, you will get like apply first formula 0 plus 4 divided by 2, right? So it will be 2. Okay, so we get the middle element 2. So what is the second element? 25. Okay, so once we get the middle element, now we need to decide. Okay, but before deciding, we need to first check if the middle element is only your desired element. Okay, so what is my desired element? 32. What is the middle element? 25. Okay, are both same, right? What first thing you want to check? 32 equal to 25? No, right? No. So our first thing is, first condition is checked and we found no, it's not same. Now I need to decide whether I need to go left side or I need to go right side. But how? We know, because element is sorted. Because 32 will obviously come after 25 only, right? It is not possible it will be present before 25. Why? Because array is sorted. Correct? So here I need to check, okay, if the middle element is smaller or greater than your expected element. So is 25 greater than 32? Okay, no, 25 not greater than 32. So here in this case I need to ignore all the elements including middle element left side. Okay, means I need to ignore 10, 21, 25. Okay, means all the left element I ignore because I know that I need to go right side. Okay, so here your starting index will be updated as what? Mid plus 1. Why plus 1? Because we need to skip the middle element also, because we know that that is not my desired element. Okay, so middle plus 1. Okay, so and after this your end index will be as it is, means we are not changing here at least. Okay, so once the second condition is satisfied, we have now a smaller array. Okay, we'll have the array with the two elements only, like 32 and 46. Why? Because we have found, we have derived the logic like I need to go right side. So what we have now? We have an array of two elements only. Now the same logic we need to try again till we found the element, or we have some exit criteria that I will explain. So here again, so here my starting index will be again 0. Okay, end index will be length minus 1. What is the length? 2. 2 minus 1, 1. Okay, so and how to find the middle element? Okay, it will be 0 plus 1. Okay, divided by 2, it will be 0.5. Okay, so generally if you are trying to find the middle element and you find something like decimal, okay, like here 0.5, so you need to take the float value. In Java also it will give you the float value only. So float value means it will be equal to 0 actually. Okay, so we found the mid element as 0, that means the starting one. Okay, so so what I need to do? First thing, I need to check the middle element is my expected one or not. Okay, here, yeah, really 32 equal to 32, right? We got the condition here. Okay, 32 equal to 32, correct? So as soon as we find, there is no need to do anything, because we found the element, like element is present here, right? Why to go further? Our logic will be terminated. Okay, so now take another searchable element which will go to third condition. Okay, suppose I want to check for 10, or let me check for 21. Instead of 32, we are going to check for 21 now. Okay, so I'll put 21. Okay, so this middle element will be same, middle element will be same again here. So instead of 32, what want to check? So here I need to check if 21 equal to 25. No, right? 21 is not equal to 25. So we need to go to check whether I need to go right or left. How to check? In the second one, I need to check if the 21, okay, which is my searchable element, is greater than the middle element, like 25. No, 21 is not greater than 25. Okay, so this condition will be false again, right? Now the third thing we need to check here, if 21 is lesser than 25. Yeah, 21 is lesser than 25, that is middle element. So this time I need to go left side. Why? And I can ignore all the elements including the mid element, which is present at right side. Okay, so in this condition we need to update the end index. Okay, so earlier we were searching from first from the 0 till last. Now we have a smaller array now, because we know that element can be present in the left side. Okay, so from in the starting index will be same now, but end index will be updated now. Okay, no need to go till last. Okay, so end index will be updated as, okay, mid minus 1. Remember, when we need to go right side, so that time we do plus 1, right, from mid element. But this time I need to go left side, and I need to ignore the middle element as well. So mid minus 1. Okay. So here we will have new array, and in that we will have 10 and 21. Yeah, so after ignoring all the right elements, I have left with only two elements, 10 and 21. Okay, so again here starting index will be same as it is, end index will be again same because 2 minus 1, 2 is the length, and mid element will be again 0. So what is the mid element here? We have 10. So here we need to check if to middle element. So what I need to check here, if the middle element, which is 10, equal to 21, which is desired element, no, right? No. So when this condition is not satisfied, then what we need to do? We need to check whether I need to go left side and right side. Don't worry if you don't have so many elements here, but we need to apply the logic. Okay. So what is the second condition we need to check? If the middle element or the searchable element, that is 21, is smaller than 10, greater than 10. Yeah, it is greater than 10. So what I need to do? I need to go right side, right? No, there is no need to go left side, include the middle element. So here your starting index will be updated as what? It will be mid plus 1. Okay, means 0 plus 1. It will be 1, right? Okay, so I have only one element left now because we need to ignore this 10. So I am left with only one element, that will be my 21. Okay, so here your starting index and end index will be same. Starting equal to 0, end will be 0. Okay, and mid will be what? We are writing the same logic. 0 plus means 0 plus 0 divided by 2, it will be 0. Okay, and what I have to check? It is like this element is my desired element. Yeah, we got the element, like the middle element is every desired element. Okay, so this was the actual logic. This is the actual logic which we need to implement. Okay, so the only major funda was here, you need to decide, or you first need to find the middle element. We have two formulas, you can do it. If you are getting the integer, then you are good, but if you are getting any decimal like 1.5, 2.5, so it will take the floor value. Okay, floor value of 1.5 will be 1, for 2.5 it will be 2. Okay, not 3, floor value. So you need to take the middle value, then you need to compare if the middle element is your desired element. If yes, then you are well and good, no need to do any iteration, and you can terminate the loop or terminate the process. But if the middle element is not your desired element, then you need to check whether your middle element or your searchable element is greater than your middle element. If yes, then you need to go right side. You need to search for element right side of your middle element. Okay, but if your searchable element is lesser than middle element, then you need to look at the right side of your middle element. Okay, this is the concept. Okay, but so here if you see, in this case, in the second scenario, we traverse till the last. Okay, where the starting and end index are same. Can you see? Right, in the worst case we need to go till there, till the last element, not the last element, till the time when we have only one element in the array. Okay, suppose we were looking for 22. Okay, 22. So suppose if we get the element with only one element like 21, and obviously we are looking for 22 which is not present in the array itself. Okay, which is not present in the array itself. Okay, so suppose so in this case 21, your middle element, will be lesser than your searchable element, like 21 is lesser than 22. Okay, so we need to go right side. Okay, but there is no element, means we need to update the index, right? We need to update the starting index. So your starting index will be again 0 plus 1 divided by 2, sorry, 0 plus 1, middle elements plus 1, because I need to go right side. Okay, so your starting index will be 1 in this case. Okay, and element will be 0. So in actually this is not a valid case. Okay, because starting index cannot go beyond end index, right? At this position, starting and ending end index both are at the same index, right? It's not a valid case in which start will cross the end index itself. No. So in this case we need to exit. Okay, so we have two exit criteria here. First exit criteria, if you find the element, means you are looking for middle element, and if middle element is the same as the searchable element, you need to terminate. Or your starting and end index are same, or you can say when till starting is less than or equal to end index. Okay, we need to keep continuing this process. Okay, so two things we need to get it from here. First thing, logic we are clear, like just need to update. If you want to go to right side, okay, from middle element, then you need to update the starting index. Okay, but if you are need to go left side, then starting is already fixed. We need to move the end index from the current to the middle minus 1. Okay, so let me write a summary here. Check, first condition will be middle equal to element. Okay, if this is the case, no need to do anything, you are good, you can terminate your exit your loop. Okay, or whatever logic you are writing. If first condition is not satisfied, they have to check if the mid element, okay, is greater than your searchable element or element. Okay, so in this case actually mid is greater than your searchable element. Okay, means your element will be present at left side, right? All the small element from the middle element will be left side because array is sorted. So in this case you need to update the end index. Okay, it will be mid minus 1. Why mid minus 1? Because I need to ignore the middle element as well. In the third case, suppose the second condition is not satisfied, then you need to check if the middle element is lesser than your searchable element. In this case we need to go right side, right? So in this case you need to update the starting index. Okay, it will be your mid plus 1. Okay, this is the logic, and actually this is called binary search. Okay, and this is much faster than your linear search. Okay, because in linear search you need to go to end comparison. Okay, but here no, you are with each pass you are actually sorting, actually you are getting the smaller array. Okay, so let's jump to Eclipse and write the logic. So here already I created one class called binary search, and I have one array, the same array which I took an example. Okay, so like 10, 21, 25, 32 and 46, and the element to be searched is 31. Now we need to write the logic. Okay, whatever we just learned. So two things will be simple, like first need to get the starting and end index. So let me store in a variable called start, and it will be 0, right, by default the first index, and the last index you can find using the length, means array dot length minus 1, that will be your end index. Okay, at the beginning, at the starting. Okay, before we start checking the condition and all. Okay, so from that previous example we know, like, we need to iterate, or we need to continue the process till when? Till start or end index are same, or much better when the start index is less than or equal to end index. Okay, because when starting index is crossing the end index, that means they no need to continue. So what is the condition? start must be less than or equal to end. Okay, right? Because we already seen that one. So once we inside the loop, first thing what we need to do, we need to find random element. No, not random element, middle element, right? Random element was for the book example. So let me declare one variable mid. Okay, and you know that how to find. Let's go with the simple one, means start plus end, and it should be divided by 2. Okay, and this will give me the middle element. Okay, once we get the middle element, we need to have 3 conditions to check. Okay, and that will help us to decide what is the first thing. If you're very lucky, your middle element will be only the your desired element. That means array of mid equal to what? Your element to be searched. Okay, if yes, then you can print sys out element found at index. Okay, plus it will be your mid. Okay, because that is the middle element will be only always the index where the element is found, if it is present. Okay, once you find the element, what we need to do, we need to break, no need to go further. Okay, then else if, you can have multiple if also, but yeah, else if is better. So what is the thing, we need to decide if the first condition not satisfied, then we need to decide whether I need to go right side or need to go left side. So if your middle element, okay, if the middle element is what, greater than your element to be searched. Okay, in this case means middle element is greater than your searchable element. Okay, so obviously we need to go left side, right? Left side. So that means we need to update the end index. So in this condition, your end index will be updated as mid minus 1, right? Left side, we are moving left side. Okay, third condition, there is no need to write whether it is lesser than, because that will be obviously the case, only one case is possible. Okay, so in that case we can directly put like start index, because if your middle element is smaller than the element to be searched, obviously the elements will be present at the right side. Okay, then we need to update the start index, so it will be your mid plus 1. Simple, just we are sorting, just we are shorting the array, not sorting, shorting the array. Okay, so if you are coming out of this loop, okay, obviously element is not found. So what you can do, you can write sys out element not found, right? There's no need to check any condition, because if the element is found, then this will break the loop. Okay, no, sorry, this will break the loop and it will come again here, so it will print element not found again. So that's not the good thing. But what we can have, we know that after, if this statement is not run, okay, then obviously after this while loop, okay, it will be, means when this condition is getting failed, that means your start index will be greater than your end index. Okay, if this is the case, obviously element is not found. Okay, so let me run this program and see if I have written the correct logic or not. Okay, so okay, oh, I started with the negative only, so 31. Okay, element is not found. Let me change to 21. Okay, so let me run this one, and yeah, element found at index 1, right? 0 1, right? Then let me put it 46. Okay, so it will be your element found at index 4. So 0 1 2 3 4, right? So that's all in this video. I hope that I tried to explain it in the layman terms, but still if you have any doubt, please comment on this video. So if you notice here, I'm not updating the start and end index again inside the while loop. But if you see here the examples, so here I was updating the start index, means actually I am reassigning. Here that just it was for the demo purpose. Okay, but if we want to keep the track at which index element is found, okay, don't reset the start and index value. Just you need to change, right? So here if you see in the code, here I have defined at the first, right, a started and index. After that I am simply moving the pointer. Okay, so it will always keep the actual indexes of the elements. Okay, so it will not impact the middle and last element, it will always go in between only. Okay, it will not be like it will go some beyond or index about, no, nothing. Okay, so here, because I want to print also at which index it is present, so I'm not resetting the index again. Okay, resetting the index position of the element, I am simply just shifting it. Okay, so it will keep the correct index of the element.